a problem from the 6th edition of Modern Algebra, an introduction by John L. Durbin, section 11, integers modulo n. Now, we're asked to show that if a is an odd integer, then a squared is congruent to 1 mod 8. Now, just a reminder what that means. Let me see if I can get a marker working here for you. This right here is equivalent to, this statement right here is equivalent to saying a squared. This triple equality or congruence operator really means this equals a multiple of 8. And I'll just write that out. A multiple. And allow me to abbreviate that, please. A multiple of 8. Now, another way of thinking of that, if you like to use the divides language, that also reads that 8 divides a squared minus 1. In other words, you can write this as 8. This vertical bar just means divides evenly. 8 divides parenthetically here a squared minus 1. Okay, so that's the meaning of that congruence symbol. Okay, so did I get that written down right? Yeah, a squared, think of this like if it's a minus sign, so you go a squared minus 1 is just a multiple of whatever the modulus is, all right? Or you can think of it as 8 just dividing a squared minus 1 evenly. For example, 8 would divide 24, 8 would divide 32. All right, so let's clear this out and move along. Now, y'all, the proof is fairly straightforward. A being odd means A has to be an even number plus 1. That's what this statement says right here. Okay, so this statement right here, A is odd, okay, is equivalent to just saying A is an even number plus 1. All right. Now I use the letter K here. K could be any integer. That's a positive or negative counting number along with 0. All right, now, so carrying on, if A is equal to this, then A squared is equal to 2K plus 1 quantity squared. Now, I didn't show you all the work, but when you expand this out, you get 4K squared plus 4K plus 1. Now, notice that sometimes just factoring part of the expression is useful. That's the case right here. If you factor out a 4K from both terms, you get 4K times the quantity K plus 1 plus the 1. All right, but now if you subtract, okay, now, so I just carry this down to the next line. So we now know that a squared is equal to 4K times K plus 1 plus 1. But if you subtract 1 from this expression, you just get 4K times K plus 1, right? But here's the rub. All you see is a 4 right here. But you see K and K plus 1 are consecutive integers, so one of them has to be even, right? Either if K is even, then K plus 1 is odd. If K is odd, then K plus 1 is even, right? So there will be a factor of 2 in this piece. Let me get this. Can I get that? Yeah. That's going to contain a factor of 2, right? So that's why we can write it as 8 times m. There will be a 2 in here. 2 times 4 is 8. So it's 8 times some m, where m is an integer, all right? So we get that, and anyway, that's why it all works out. So you actually get that a squared minus 1 is a multiple of 8, like we were talking about earlier, which means as long as a is odd, this happens. Now let's just do a concrete example so you'll kind of believe it. That's just sort of an abstract proof, but let's try. It's just a concrete problem. Let's say that we chose a equal 11, right? So we'll do a equal to 11. That's an odd number, right? It's 2 times 5 plus 1. All right. Okay, so that implies that a squared is certainly equal to what? 11 times 11 is 121. You guys memorize all those squares, all right? So, but that, whoops, sorry, that should be, how do I clear this? Okay, sorry. Okay, so this should be, okay, whoops, sorry. This should be equal to 121, right? 11 times 11 is 121. But notice that 121 minus 1 equals 120, right? But that is a multiple of 8, right? That would be what, 15 times 8? Okay, so you see it works. And you get that it's a multiple of 8, therefore making it congruent to 1 mod 8, right? And y'all just think about any other, like 7 times 7 is 49. 49 minus 1 is 48. 5 times 5 is 25 minus 1 is 24, which is certainly a multiple of 8. So it works in all cases. All right, everybody. Hope you enjoyed. Thanks.